Hello everyone, thank you for this opportunity. My name is Zainab Said and together with my colleagues, I'm pleased to present our study titled Uncovering the Soil Impact of Wastewater Irrigation, a case study from Konya, Turkey. Why wastewater? Water demand is rising worldwide because of population growth and climate change. Many regions no longer have enough fresh water for farming. So, countries began using wastewater and drainage water because they are always available and cheaper. Konya is a perfect example. Large agricultural area, very dry, with serious groundwater decline. Farmers rely heavily on wastewater and drainage water, so it's important to understand their effects on soil. What is wastewater and drainage water? Wastewater comes from homes or industries and contains nutrients, salts, and some contaminants. Drainage water is the water leaving the soil after irrigation. It picks up salts and nutrients, so it becomes even more saline. In Konya, both are reused when fresh water is not enough. For the advantages, these waters provide farmers with an extra water source and contain nutrients like nitrogen, phosphorus, and potassium, so they can help soil fertility and reduce the need for chemical fertilizers. But long-term use can increase soil salinity and allow heavy metals like nickel or cadmium to accumulate and affect soil structure. If wastewater is not properly treated, it may also pose health risks, so we must consider both benefits and risks. Our goal was to see how wastewater and drainage water affect soil quality. In Konya, we measured basic soil chemistry, pH, calcium carbonate, soil organic matter, analyzed mineral composition using XRF, measured nutrients and heavy metals, and used PCA to understand variation between the samples. For the study area, we choose Konya because Konya is one of Turkey's biggest farming regions. It is very dry with declining groundwater. Wastewater canals run right beside the fields, making it easy and cheap for farmers to use. So, Konya is ideal for studying long-term wastewater effects. We collected 8 soil samples, 7 irrigated with wastewater and 1 with drainage water. Each sample was analyzed 3 times, giving 24 measurements. In the field, we also observed salt crusts, cracks, and plant condition. These photos show crops near wastewater canals. Plants look healthy, but the soil clearly shows salt deposits and cracks, indicating salinity and structural issues. We measured pH, bulk density, calcium carbonate, and soil organic matter. pH affects nutrient availability, shows salinity, bulk density shows compaction, calcium carbonate explains alkalinity, soil organic matter improves fertility and structure. pH range was between 7.6 to 8.1, moderately alkaline. was between 0.4 and 1.01 decimals by meter. But drainage water, the soil irrigated by drainage water, reached 2.95 decimals by meter. Bulk density was 1.22 gram by cubic centimeter. Calcium carbonate was very high. It even reached to 17%. Sodium organic matter low, between 2 and 2.39%. So Konya soils are highly calcareous, low in organic matter, and salinity depends on irrigation water. Nutrients and heavy metals. Nitrogen was high due to wastewater. Phosphorus was good but partly fixed by calcium carbonate. Calcium, magnesium, potassium, and sodium were high, typical for calcareous soils, but high sodium reflects wastewater and drainage influence. Micronutrients were normal. Copper slightly low. Lead and cadmium were very low. Nickel was higher in wastewater irrigated soils. Wastewater adds nutrients like sodium, nitrogen, calcium, magnesium, and potassium, and slightly increase nickel. Drainage water adds fewer nutrients but causes the strongest salinity because of high sodium and magnesium, explaining the high EC in sample 8. So, wastewater enriches nutrients while drainage water increases salt stress. These images show some of the laboratory procedures used in our study. What is XRF? XRF tells us what minerals are in the soil. It scans the soil with X-rays and detects oxides like calcium oxide and silicon dioxide. This helps us see whether irrigation water is changing the soil over time. Calcium oxide was highest between 27 and 37%, showing strong calcareous nature. Silicon dioxide around 24 to 28%. Magnesium oxide and the others were lower but variable. Sample 8 had higher magnesium and iron because drainage water brings more dissolved minerals. BC1 and BC2 explain 63% of variation. Samples 8A and 8C drainage water clustered together with high iron, magnesium, lead, copper, nickel, but the samples 1A and 1C are different with higher potassium and manganese and lower iron and magnesium, which mean less affected by wastewater. Middle samples show moderate changes. Overall, irrigation water quality explains the difference between soils. In Turkey, wastewater is increasingly used due to water scarcity. It provides water and nutrients, but untreated wastewater can cause salinity, metal buildup, and soil degradation. Studies across Turkey show similar long-term impacts. Wastewater enriches nutrients but adds some metals. Drainage water mainly increases salinity and has the strongest impact. Both change soil over time, so regular monitoring is needed for sustainable agriculture. We recommend mixing wastewater with fresh water when possible, adding organic matter to improve soil structure, regular monitoring of EC, pH and heavy metals, improving wastewater treatment, and more research on metal movement into crops. Thank you.